Hello. Hello everyone, my name is Christina Ternovska and I'm a student majoring in bioengineering at UMD. Today I will be presenting my final project report for mechanics. So, the system that I chose to analyze is a simple nail clipper. As it states in the name, it is a tool that is used to cut nails. They can be found in almost every home and they can be easily bought at any local store for just a couple of dollars. Nail clippers consist of two cutting blades and a lever arm, which can be rotated and put into a position that provides a nice mechanical advantage, making it very easy to cut through nails. I find this tool to be very interesting because it is such an intuitive design that we often take for granted. Personally, I have found that I have much more control over the evenness of my cuts, and clippers are not as likely to slip in the same way scissors can, so you can avoid accidentally cutting or poking yourself. The units that I incorporated into my analysis started with Unit 3, which is where we learned about 2D modeling and structural supports. Since the nail clipper has a pin, I modeled the nail clipper as a rigid body when it is in its most compressed state. Then, by isolating the lever arm and using a free body diagram, I was able to use moments and equations of equilibrium to solve for the unknowns of the reaction at the pin. This will be useful in finding other unknowns later on. In Unit 5, we learned about 2D rigid body equilibrium, so in a similar way I modeled the nail clipper as a rigid body in its most compressed state. I then isolated the upper and lower cutting blades and used a moment and equations of equilibrium to find unknown forces, and to find the normal force that is applied to the nail. This will later be used to find the mechanical advantage of the nail clippers. Because of the lever arm, when a force is applied to nail clippers, there is axial tension developed in the pin itself. This is where I used what we learned in Unit 7 to find the magnitude of the axial stress developed. This can be helpful in gaining a sense of what kind of stresses are going on. In Unit 8, we learned about material properties and deformation, so I calculated what the hypothetical axial force would have to be if the pin experienced a deformation of 1 millimeter. The most interesting outcome I found was the mechanical advantage of the nail clippers. After finding the reaction at point A of the lever arm, and then taking the moment about one end of the lower cutting blade, I found that the normal force developed on the nail is 19.6 newtons. Mechanical advantage is the output divided by the input, so with the input being 2 newtons, the mechanical advantage is 9.8. This means that the force applied to the nail is 9.8 times bigger than the force we used to squeeze the clippers, demonstrating the really nice advantage of using nail clippers and why they make cutting nails so much easier. Just as an example, I will show a demonstration of how the mechanical advantage makes it easier to cut through thick acrylic nails. As you can see in the video, my scissors fail to cut through the acrylic and plastic, and they slip, which isn't very safe. However, with the nail clippers, I can easily cut through very thick acrylic and plastic without any worries. This demonstrates exactly how useful the mechanical advantage provided by nail clippers can be, and how easy they are to control. That wraps up my presentation. Thank you so much for listening, and I hope you enjoyed my video.